Okay, so I want us to discuss linear inequalities, and we have to look at a point to note. Number one is the linear inequality sign, whereby we have x is greater than 2. So x is greater than 2 means the value of x are greater than 2. The value of x are greater than 2. Values means the numbers. So all the numbers of x are greater than 2. E.g., the numbers that are greater than 2, we have 3, 4, 5, 6, ... So this side means x is greater than 2. Number 2, we have x is less than 2. X is less than 2. X is less than 2 means the value of x are less than 2. They are less than 2. E.g., numbers that are less than 2, we have 1, 0, -1, -2, ... Next, number 3, we have x is greater or equal to 2. So this means that the value of x, and 2 is included, is greater than 2. So e.g., 2 is included, so we have 2, we have 3, we have 4, we have 5, and other numbers which are above 2. Next, point number 4 is x is less than or equal to 2. This means that 2 is included and the numbers of x are less than 2. Less than 2. That is, numbers that are less than 2, we have 1, 0, -1, -2. Point number 5. Our last point to note, point number 5. Point number 5 is point to note. When you divide both sides by a negative number, the inequality sign changes direction. So when you divide both sides by a negative number, the inequality sign changes the direction. So I want us to do example 1. So we have 5 points to note. Number 1, x is greater than 2. So the value of x are greater than 2. We have 3, 4, 5, 6, and many others. Then number 2, we have x is less than 2. So the value of x are less than 2. We have 1, 0, -1, -2. Next, 3, x is greater or equal to 2. This means that the value of x are greater than 2 and 2 is included. Number 4, x is less than or equal to 2. So this means that the value of x are less than 2 and 2 is included. So we have 2, 1, 0, -1, -2. Next, point number 5, when you divide both sides by a negative number, the inequality sign changes direction. So I want us to do example 1, and I want us to emphasize on, I want us to emphasize on point number 5. So point number 5 says, when you divide both sides by a negative number, the inequality sign changes direction. So I want us to do example 1. So example 1 is solve for x in the linear inequality. So we have these linear inequalities. We have 5 minus 4x less than or equal to 17. So can you find the value of x? Find the value of x. So we have our question, which is 5 minus 4x less than or equal to 17. So step 1, make x the subject. Make x the subject. So I have to take positive 5 to the other side. So when I take positive 5 to the other side, it becomes minus. So we have minus 4x is equals to 17 minus 5. So minus 4x is equals to 17 minus 5, it is 12. Next, make x the subject. So you divide both sides by a negative 4. So you get x is equals to, or it is less than or equal to negative 3. Then there is this point that I have indicated, that is point number 5. When you divide both sides by a negative number, you change the inequality sign. So as you can see, we have divided both sides by a negative 4, both sides. So when you divide by a negative number, you change the direction of inequality. So it is x less than or equal to negative 3. So can you change this direction of this sign? So this one becomes x is greater or equal to negative 3. Yes, so this is the final answer. Example 2. Example 2, we have 3 minus 4x less than 11. 3 minus 4x less than 11. So you're supposed to master the 5 points. So can you make x the subject? Make x the subject. So we have 3 minus 4x less than 11. Make x the subject. So as you can see, 3 has a positive sign. So if we take positive 3 to the other side, it becomes minus. So it is negative 4x less than 11 minus 3. So you take minus 4x less than 11 minus 3. 11 minus 3 is 8. Make x the subject. So as you can see, I have to divide both sides by a negative number, and that is negative 4 by negative 4. So x is less than negative 2. Then I have said, if you divide both sides by a negative number, you change the direction of inequality sign. So this one becomes x is greater than negative 2. Please note point 5. When you divide both sides by a negative number, you change the inequality sign, the direction of inequality sign. Example 3. Example 3, we have 5x minus 12 less than or equal to 3x plus 3. Can you make x the subject? So our question is 5x minus 12 less than or equal to 3x plus 3. So we are supposed to separate numbers with letters and numbers without letters. So that means that I have to take plus 3x to the other side and minus 12 to the other side. So this one becomes 5x minus 3x less than or equal to, we have 3. When we take negative 12 to the other side, it becomes positive 12. Higher, simplify. 5x minus 3x is 2x. Less than or equal to 3x plus 12 is 15. Can we make x the subject? So you divide both sides by 2 by 2. So the value of x is equivalent to, so x is less than or equal to 15 divided by 2 is 7.5. And this is the final answer. If we could divide this side by negative number, we could have changed the direction of the inequality sign. But in our case, we have a positive number. So if you divide both sides by a positive number, we don't change the inequality sign. Next, example 3, we have 3, open the bracket, 4x minus 2 greater or equal to 6. Our aim is to solve for x. So as you can see, we have to use BODMAS. Open the bracket. Can we open the bracket? So if you take 3 times 4x is 12x. 3 times negative 2 is negative 6. Greater or equal to 6. Next, make x the subject. So that means I have to take minus x to the other side. So if you take minus 6 to the other side, it becomes positive. So this one becomes 12x is greater or equal to 6 plus 6. So this one becomes 12x is greater or equal to 6 plus 6 is 12. Make x the subject. So divide both sides by 12 by 12. So as you can see, x is greater or equal to 12 divided by 12 is 1. And this is our final answer. Next, example 4. We have negative x plus 12 greater than 0. Make x the subject. So I have to take positive 12 to the other side, and it becomes minus 12. So you take negative 6x greater than negative 12. Make x the subject. So you divide both sides by negative 6 by negative 6. So x is greater than, so when you divide both sides by a negative number, I have to change the direction of inequality sign. So you're supposed to take negative 12 divide by negative 6. Negative divided by negative becomes positive. So 12 divided by 6 is 2. Next, I have to change the direction of inequality sign because I have divided both sides by a negative number. So this one becomes x is less than 2. That is the final answer. So x is less than 2. So as you can see, we have divided both sides by a negative number, and I said if you divide both sides by a negative number, you have to change the direction of inequality sign. Next subtopic, I want us to solve linear inequalities by using graphical representation. So next subtopic is graphical representation. Graphical representation. So we have points to note. So number 1, we have the sign is known as greater or equal. Greater than, that is. This is greater than. Then we have less than. So in the graphical representation, greater or less than, it is represented by a dotted line. Number 2, greater than or equal to or less than or equal to, it is represented by a continuous line. It is represented by a continuous line. Next, number 3, point to note, always shade the part which does not satisfy the inequality. So always shade the part which does not satisfy the inequality. So this is where you do a test point, whereby you pick a point. If it is true, so test point, you are testing the side which is true and the side which is false. So if you identify that side X is false, you shade that side which is false. So false means that that part does not satisfy the inequality, but true means that that part satisfy the inequality. So false does not satisfy the inequality. So I want us to do example. So I want us to do our example 1 for graphical. So we have example 1. You draw x greater than 3 on Cartesian plane. So we solve this one. So you're supposed to draw our Cartesian plane. So this is our Cartesian plane. So this is a y-axis and this is x-axis. So x-axis, I'm going to use 1, 2, 3, 4, 5, 6. Then y, I'm going to use 1, 2, 3, 4, 5. This one is -1, -2, -3, -4. So x is greater than 3. Point to note, I said less than or equal to, less than or greater than, it is represented by a dotted line. So I come to x-axis, I represent x is greater than 3 using dotted line. Next, I have to do test points. I have to identify the points, the part which satisfy the inequality sign. So we have x greater than 3. So test point. So I have to pick a point, then I prove whether it is true or false. So can we look at this line? So I have to pick a line, a point. So on your left, so this is left and right. So on your left, can you pick a point, one point, the value of x? So you can pick 1 as x. So after picking the value of x as 1, you come back to your original question, which is x is greater than 3. You insert that value, and I took 1 as the value of x. So is 1 greater than 3? Is it true or false? Is 1 greater than 3? So this is false. There is no way that 1 is greater than 3. Next, right hand. You pick a point. You can pick 4 as the value of x. So you write, come back to your original equation, which is x greater than 3. Insert that number. So is 4 greater than 3? Yes, so this is true. And I said we are supposed to shade the part which does not satisfy linear inequalities. So the side that does not satisfy linear inequalities is the side that indicates that it is false. So I have to shade the left side. So this is unwanted part because it does not satisfy linear inequalities. So that is example 1. Example 2. Example 2. So we have example 2. We have y is less than or equal to 5. Y is less than or equal to 5. So solution. You're supposed to solve this question using graphical. So step 1, you draw a Cartesian plane. So this is x. This is x axis and this is y axis. So this is 1, 2, 3, 4, 5, -1, -2, -3, -4. Then 1, 2, 3, 4, 5, 6, -1, -2, -3, -4. So as you can see, y is less than or equal to 5. And I said less than or equal to. We normally present it by continuous line. So as you can see, the value of y is 5. So you draw a continuous line at y-axis. Then test point. Just pick a point below the line, above the line. Below the line, 4. Above the line, 6. So below the line it is 4. And our original linear inequalities is y less than or equal to 5. So when y is 4, is it less than 5? Is 4 less than 5? Is 4 less than or equal to 5? Higher. Is it true or false? Is it true or false? Next, above the line, 6. Is 6 less than or equal to 5? Is it true or false? 5, 4 is less than 5. This is true. So this one is true. Next, 6 is less than 5 or equal to 5. False. So you shade the part which does not satisfy linear inequalities. So 6 is above the line. So we shade the unwanted part. So that is the unwanted part. Next, we have 2x plus y less than 6. We solve graphically. So step 1, make y the subject. Make y the subject. So 2x plus y less than 6. Make y the subject. So this one becomes y less than 6 minus 2. Step 2, construct a table. The value of x and the value of y. So when x is 0, y is 6. Higher. When x is 1, y is 4. Next, when x is 3, y is 0. Step 2, you construct a Cartesian plane. So this one is 1, 2, 3, 4, 5, 6, -1, -2, -3, -4. This one is 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, and -5. Allocate the point. We have 0, 6. We have 0 and 6. Next, we have 1 and 4. Next, we have 3 and 0. Next, is it dotted or continuous? Less than, it is dotted. Next, test point. True or false? Above the line, below the line. So now we have to pick a point. So it is good to pick point 0, 0. So if this one indicates that it is false, you shade that part. If it is not false, or if it satisfies the linear inequalities, that means that the other side is false. So we can test the linear inequality by using 0, 0. So this one is left, right. So x is 0 and y is 0. And our question is 2x plus y less than 6. Insert the value of x. 2 times 0, 0. Plus the value of y is 0, less than 6. 0 plus 0 is 0, less than 6. Is 0 less than 6? Is 0 less than 6? Is it true or false? 0 is less than 6. This is true. If it is true, it means that the left side is true. So I have to shade the right side. So this one does not satisfy linear inequalities. Or you can just pick a point on your right. You can just pick 4, this point, 4 and 4, 0. Or you can just pick 4 and 1. Can we check whether it satisfies linear inequalities? So our question is 2x plus y less than 6. So the value of x is 8. is 4. So y is 0. So 2 times 4, 8, plus 0 less than 6. 8 plus 0 is 8. Is 8 less than 6? No. So this one is false. So we shade this part. Unwanted. So this one is unwanted part. So this one is false. Higher. Next example.